Okay, thank you all very much for signing in to today's session. We'll be looking at implementing Inspire with FME. This is one of the series of webinars that we're delivering throughout the last few months. We've looked at FME for MapInfo professional users, we've looked at FME for AutoCAD users, we've also looked at some of the latest changes in FME 2012, and in about 4 weeks' time we'll be looking at the use of FME with data.gov.uk. So a series of topics, roughly 1 hour training sessions, free to sign into. My name's David Eagle, and I'm going to be taking you through this session for the next sort of 50 minutes or so. So once again, thank you for giving up your time over this lunchtime to listen to this session. The agenda for the day, we're going to be looking at Inspire in detail, looking at some of the deadlines that are coming up, and the importance of those deadlines that have appeared to you. We'll be looking at auditing your data holding, what return on investment you can get from identifying what data you have access to and where it is, and how you can use technology to assist you in that task. We'll also look at data quality. It's always an important part of your data audit to understand the quality of your data and ultimately understand what elements of the data are fit for publication. We're going to take a look at how you can go about harvesting metadata to standards like, for example, UK Gemini. We're also going to look at your ability to publish Inspire conformant GML using tools and principally using FME Desktop. So that's our focus for today. OneSpatial. We've been around since 1969. I'm not going to give you too much detail about our organisation other than letting you know that our focus is all around your asset data. We work with a number of organisations to deal with data quality, data manipulation, and data translation. And we've got a large number of clients in the National Mapping Agency space. So we do a lot of work with Ordnance Survey and Ordnance Survey Ireland and Ordnance Survey Northern Ireland, or LPS as they're known, and also a number of other organisations like the Environment Agency. Safe Software, on the other hand, are the vendors of the product that we're going to be focusing on, FME Desktop. They've been around since about 1993, and they occupy a very niche but also a very unique space because they produce some technology, two main products, one called FME Desktop, one called FME Server, that sit between all of the major data and GIS and CAD vendors, and gives you the ability to move data, for example, from an Oracle database through to MapInfo professional tab files or MicroStation design files through to PostGIS. And really they've been around, as I say, since '93, giving them a unique position of capability with now, with the latest iteration of the product, FME 2012, support for over 278 different formats and the ability to transform the data between those formats or even within the same format. We have a number of capabilities when it comes to FME, and we have now 4 FME certified professionals and 3 FME certified trainers that can provide dedicated services around the FME toolset. Some of those services that we spend our time on are actually looking at evaluating the product, so we'll help you understand how to get the best out of the FME product before you purchase it. and that's a service that we offer as a value-added reseller to Safe Software. We also provide a number of consultancy services, an assortment of FME training classes, both in our head office in Cambridge, in Sydney, in Australia, and also at your offices when you require that training. And we also provide technical support services. I notice from the subscription that there are a few people that are new to FME, so I'm going to offer a brief overview of the capability. Really, FME as a product, I've already mentioned, has a number of data formats that it can work with, and those data formats are plugged into a central engine that carries out an ETL task, an extract, transform and load task. So it takes your data from whatever formats it's in, so it might be stored in a MapInfo tab file, and FME knows that it can process that through to an Esri shapefile. Shapefiles can be read and can be written out to GML, and GML can write across to Oracle. So, as I say, lots of different formats are supported, but largely the power and value of FME is unlocking your data from those data formats and getting it into an area that it can be processed and transformed, restructured, generalized, thinned, joined to other data. And it is a centralized processing engine that does that work for you. When you buy FME Desktop, you get all of these tools. So you get the ability to use a program that you'll see plenty in this webinar called FME Workbench, which is your authoring tool. You also have access to the FME Universal Viewer and the Data Inspector for both 2D and 3D data visualization. You have access to a quick translation tool that will translate your data from one format to another very quickly with very little fuss. You also are licensed to use the FME software development kits to build your own programs that have FME embedded underneath the bonnet of your applications. And you also get an FME application extender utility, which allows you to essentially inject your FME license across into the product that you also have installed on your machine. That might be an Esri tool, it might be AutoCAD, it might be MapInfo Professional, and that will allow you to work with your standard GIS or CAD tool in the normal way that you operate, but also get a little benefit from your FME license, so that you can natively open different file formats within that application. So it's a very powerful tool, and you get a number of different components to work with. Now, in this webinar there are going to be some blue slides every now and again. They're going to indicate the break in the presentation to move to another topic. You're more than welcome to put notes or chat or questions into the chat window during this webinar, and we'll try to address any questions you've got at the time or at the end of the session. So please feel free to do that. So I'm going to spend a few moments just looking at the Inspire deadlines that are coming up and what Inspire is mandating that you have to do and when by. But first of all, it's worth noting some of the annex details of Inspire that not everybody is aware of. So there are 3 annexes in the Inspire program, and you can see that Annex I contains some common things like coordinate reference systems, geographic names, addresses, hydrographic information and protected site information. And organisations that fall into those categories are the likes of the GRO, the General Register's Office for Scotland, British Waterways, the Environment Agency for England and Wales, Natural England, Countryside Council for Wales, and the Scottish Government. So a number of organisations have data sets that are address-based or they are environmental-based, so protected sites, and they have or are mandated to provision that data under Annex I. Annex II includes 4 themes only: elevation, land cover, orthoimagery and geology. So again, the likes of the Environment Agency also has some data sets that fall into the Annex II category. The British Geological Survey also have data under Annex II, Theme 4 of Geology. Annex III is a much longer list, and actually this is one with a slightly longer timescale to the other two. So it means that a number of organisations are starting to identify what data they have that falls into the Inspire theme. So certainly organisations like the Scottish Government and Scottish Natural Heritage have already identified some data sets that they've got that fall into Annex III, but organisations like Natural England are going through that process at the moment to identify if they've got any data sets, and if so, which data sets fall into those categories. The reason that I've included the Local Government Association on that list is because largely local government bodies fall into Annex III, or may have some data sets that fall under this annex. So it's worth getting in touch with the local government organisation, Local Government Association, because they are starting to work very closely with local government to help them understand what they have to do and by when. And to give you some high-level dates, some of the deadlines that are listed here, for example, you can see that this slide is largely grouped into metadata, and also the publication of new and the publication of existing data. So you can see that if you had data falling into the category Annex I and II, then you should already have made metadata available since December 2010. Annex III data needs to be made available in about 18 months' time, so you have a little bit of time to get your ducks in a row in terms of prepping your data to be able to provision metadata for it. When it comes to publishing new data products, so if you have any brand new data sets that fall into Annex I, that's something that you are probably doing already. 2015, 17 and 2020 are the headline dates for publication of new data for Annex II and III, existing data for Annex I, II and III. So the requirements stretch out into the future a little, but it's surprising how quickly these dates can creep up on you. And even if you're in the category of having had already produced metadata for Annex I and II earlier in the last year or so, some of the things that we're going to be talking about today will give you the ability to update, maintain and manage that metadata. So, auditing your data holding. One thing I wanted to do in this session is share with you an approach that we've taken with a number of customers already to assist in data auditing. I personally refer to the data that you have in a number of different ways, but I often talk about the 3 C's. So that's all about condition, currency and coverage. So if you go and take a look at the data products that you have access to, or those that you have been creating or managing, if you look at the condition of the data, the quality, you can identify how accurate it is. You can look at the currency of the data to see if it is a data set that's maintained every fortnight, or whether it was just a snapshot in time that was taken in 2005, for example, or whether the coverage is an appropriate geography for more than just yourself to use. Because taken together, all of these 3 things can identify whether the data is fit for purpose. It's very common that we see examples of organisations maintaining data sets in one department and maintaining a very similar data set in an adjacent department. So there's duplication of effort there that we need to take a look at, and a data audit can expose the truth about where data is and who's managing it and how important it is to different organisations. So really the return on investment that you can get from going through the process of carrying out a data audit can be very important, because it also identifies what formats of data you have on the network or in your organisation, and if format is a barrier to progress. So are different people in your organisation struggling to get access to the data because it's not available in an interoperable format that they can work with? Ultimately, the end game is generally publishing that information, and it needs to be fit for purpose and of an appropriate quality before you can start publishing it out into the public domain. Generally, getting your quality right is the difference between proactive and reactive processing or progress with your data. So this is what I wanted to share. It's just our approach to looking at a data audit. We go through a series of stage gates with an organisation. So we'll take a look at the key data sets that you have and assist with working out how those data sets support the business. And this is an exercise that you can go through yourselves, independent of any organisation. It's a good workshop approach that gets all the heads of departments around a table to understand what is the most important data that you manage and what's the most important data for your business, and document that so that you can make sure that there is a case for that data in your business plan in the future. We then also help carry out some data integrity checks and look at the quality and the conformance to the rules that your data has, and in the rest of this webinar we'll look at some ways in which you can apply technology to help you with that in that series of stages. And we can also assist in looking at reducing the duplication that happens around your network to make sure that if you're wanting to migrate to a database, or if you have migrated to a corporate database, that the data in the database is the most up to date and there aren't files on the network that are being used more frequently than that database connection. Ultimately, we'll collate all of this information into a report that will be presented to you so that you can see how your data plan is running within your organisation to make sure that your data is fit for purpose and essentially Inspire ready. So just to give you a little bit of assistance, what I want to do is throughout this session give you a few FME demonstrations. One of the very early tasks that an organisation needs to do is just physically find your data. I've put together a demonstration that shows you how you can use FME to essentially trawl your file server for data and return some high-level metadata about that information. So what I'm going to do is just open up FME Workbench. So this is FME Desktop's Workbench tool. I'm going to drag a pre-configured FME workspace into view, and those of you that have seen or actively work with FME will be familiar with this interface. Essentially, FME Workbench is a tool that allows you to write code, but without having to write code. So you can define an input, and here I've got two inputs, and you can define an output, and I have one on the right hand side. The workbench reads from left through to right, and these blue things in the workflow are transformers that carry out individual tasks. What I'm doing is I'm using a very special reader called the generic reader, which allows me to write a workspace that doesn't know at runtime what format of file it might receive. I'm also supplying a reader, again another special reader, rather than using a shapefile reader or a tab file reader or a connection to an Oracle reader. I'm using a directory and file path reader. If I just zoom in on this lower part of the workspace, you can see that what it does is it doesn't necessarily read the data, it reads the location of the data, and it returns things like the file size, the owner, whether the data is read-only, where the data is stored, and what the file extension is. So high-level Windows metadata. So if I just run this process and then I'll start talking you through it, I'm going to point this process at a series of directories searching for different types of vector data that's of interest to me, and you can see that I've also got a raster data set in here that I'm looking for. So I'm looking across my network for tab files, shape files, TIFF files, etc., etc. And if I just open up a folder, you can see that this is the file path that we're looking at, and you can see that in here there are some subfolders, but we've got some tab files, we've got some drawing file, Esri shape file data, we have some MicroStation design files, some TIFF files in here, so a complete assortment of data sitting on a file path here. And what we're going to do is just dive over to the workflow and read in from that network some of that data. So we're also going to write out to Google Earth, so we're writing out to a KMZ file, and I'm just going to start that process and it'll trawl the network. So you can point this workflow at any part of your file network if you wanted to. You could run it straight by looking at the P drive if you wanted to, or your M drive, or whatever network path you have. And you can see that what I'm doing is I'm reading any data in, I'm deriving or finding out what the coordinate system is, exposing the full file path for that data set as well. I'm also extracting parts of the file name. Ultimately though, I'm aggregating all the geometries together by file and then extracting the bounding box of my data set. So what I want to do is make sure that I extract the min and max x and y values of my data so that we can get some bounding box information and create essentially a rectangle on the map, which is what I will do. So at this point, for every file that I've found, and you can see that I've found 39 of the file extensions that I was looking for, I've created a polygon which I'm going to join to the Windows metadata information, so things like the date that the file was created, and you can see that also I'm capturing the owner name and when it was modified and last accessed. Join that information onto the geometry, and then I dive over to the end here and you can see that I'm doing some rudimentary duplicate removal. In this case, all I'm doing is removing duplicates where the file name is the same. So anything that looks like it's a duplicate, I'm styling differently using the KML styler because that's my output format. And I'm writing the data out to KML. Now if I just show you what I'm talking about here, I'm going to open up the Universal Viewer, which is another tool that you get with FME. And if I just dive over to my data input directory, you can see that if I open up this tab file here of battlefield sites and just read it in, you can see that we've got a series of polygons stored in the data, and essentially what I'm going to be deriving from my workflow is a bounding box of this complete data set with some high-level information about that data set, as well as all the other data sets of appropriate type in that folder. If I go to my output directory, you can see that this process has successfully completed and it's run through. So if I go to my output and double click on the KMZ file, it'll zoom in and you can see that I have a file Audit here. The Audit shows me grouped by file type the data that I have around my network. So if I just turn everything off and turn on all the tab files that I've got and zoom into the United Kingdom, you can see that I have a bounding box that covers all these different areas, and if I click on one of them you can see that this is a ferry mapinfo table. It is owned by myself, it's stored in British National Grid and there's its bounding information, and it was modified on January the 6th, 2011. If I dive into this table, you can see if I turn off a few of the layers, perhaps a data set we might not have spotted is an industrial file that's stored as a tab file and covers the extents of this industrial estate down in the southeast. So we can quickly identify where data is geographically as well as where it is on the network. If I just go and take a look at some of the TIFF data and zoom out a little bit in Google Earth, you can see that I have a number of TIFF tiles of data stored in Scotland. So we can see that we have some extents of Ordnance Survey data, 1 to 250 thou, raster data covering part of Scotland here that I've found on my network. If I dive and have a look at the mid-MIF data and just zoom out a little bit, you'll notice that not only do I have some data over in Great Britain, but I have some down in America, in Austin, Texas, and we can see that we have an assortment of data here. And if the data bounding box is in blue, it probably means that there is a similar file name. So we can see that we have, if I turn off and show you parcel K24 as a feature, we have another feature that covers an identical geography with the same name, but it's on a different file path. So that's probably a duplicate file. So this process really just helps us understand where data is on your network, what geospatial files you have lying around, and any basic duplication that you have on the network. Once you've found the data though, the next task is to consider going about improving the quality of the data and make sure it's fit for purpose, as well as removing any duplication that you have. Inspire is an interesting program because it's very much can be seen as a catalyst for data quality. A number of years ago in the UK, what went on was a positional accuracy improvement program, very similar to the program that's been underway in Australia in recent years, and also is going on in Ireland at the moment as well. So what that program meant was that the Ordnance Survey made a change to the base map and improved the quality of it, and it was marketed by the Ordnance Survey as a catalyst for data quality, because as you go ahead and shift the base map, you have to move your asset so that it snaps to the base map appropriately as well. But it's also necessary or helpful at the same time if you can go about improving the quality of it. So what we can do is treat Inspire as the same way. Inspire is mandating that we go ahead and publish our data and aid discovery of it through metadata, but we want to make sure that it's of an appropriate quality before we start publishing it. The first step though to conforming to Inspire is making sure that you're ready by understanding your data, and actually one of the largest challenges in my experience is assigning ownership of data, making sure that an individual in your organization understands a data set intimately and understands the frequency that it can be that it's being updated, and is able to maintain the information about the data as well as the data itself. So we'll take a look at a couple of different approaches to data quality, and we'll look at it first on the desktop. As you'll know perhaps already, FME is pretty much the de facto tool for translation and transformation, and quite a few organisations have invested in FME already for certain tasks, like carrying out a data migration to a database. But a lot of organisations don't realise that FME can be repurposed for a number of different things, and data validation is one of those. It'll help you spot your data problems. And I'll show you a couple of mechanisms for doing that now. I'm just going to tidy up a little bit by closing a couple of my workflows. And I'm going to just open up a process that I've prepared for data validation. So we'll look at this process as a basic overview and then a more advanced one. And what I'll do is hopefully highlight a few interesting transformers for you. The transformers are the blue items, and what I'm doing in this workflow is using that generic reader again to give me the ability to bring in some data no matter what the format is to this workflow. I've got a simple process in place that, if we just navigate down here, essentially extracts, using a transformer called the file name part extractor, extracts the name of each file and writes that into a new attribute. In this case, I'm taking the file name extension and dropping that into an attribute. And then I'm using a number of different transformers, and FME 2012 introduces a few new transformers that you can use to clean up your data. For example, there is now a sliver remover. But you can see here that I've got a transformer called the spike remover in place, which allows me to either identify where spikes appear in my data, or using this flagged port, which would write a point out to show me where the problem is. Alternatively, I can actually physically change the data to remove the spikes if necessary. The geometry filter splits the data up, and I'm using the donut hole extractor to identify where there are holes in my data. And bear in mind that if you find large holes, those large holes could be lakes or rivers, so it's probably necessary to do a bit of analysis on the size of the holes in order to work that out, but you'll see that in a moment. And then a very useful transformer to be aware of is the geometry OGC validator. This searches and checks for 12 different types of problem in your data. Some of the more common ones, like self-intersection and ring self-intersection, are interesting to find, because you can then subsequently go ahead and fix them and then put that data back into your workflow without having to have a manual process in place. So certainly when you're writing into a database, the geometry OGC validator helps you prep your data ready so that that feature will be accepted by the database. So I'm going to use a mechanism in FME called prompt and run, and this allows me to pick the files that I'd like to process, and I'm just going to read this DWG, and I'm going to read a Terrier dataset, which is in shape format, and read those through into my workflow. And I'm outputting the data not to a file but to the universal viewer, just so I can see what's happening to my data. And you'll see that when the universal viewer opens up, it gives me an indication of the drawing file original and where there are spikes in that data set. So if I just zoom in on a particular feature, the red marks that you see, or the red spots that you can see, are highlighting spikes in my data, or potential problems in my data. And if we zoom in a little bit more, you can see this is an exact problem that we're trying to get rid of. These spikes are potentially snapping errors where that node should actually have been snapped to that point, and we're identifying that from the DWG here. If we turn off some details, we can go and have a look at the self-intersections and ring self-intersections that feature in that same data set. So we can zoom in on a particular area and take a look and see if we can find any problems with this feature, and turn on the original data to understand what the problem is. So it's a very useful tool to be able to spot problems in our data, and we're just using this in a basic way to identify where those issues are. Another approach is to use a slightly more advanced version, and that is one that I'm going to show you now, which is a series of transformers that read in any data but write out the problem data to a format of your choice. So what we can see is that the latter end of this workflow, if I just prompt and run this, you'll see that one of the questions you're asked for is what format would you like the problem data to be written out into, and you can decide whether you want the data out as a mid-mif or a shape. So you'll get some points on the map in the appropriate format based on what you ask for, and that's done using this parameter fetcher. The parameter fetcher goes and gets what the user, the value that the user entered, and then we test to see whether the user chose to write the data out to mid-mif or not. And if they didn't, they wanted it to be shape, it goes to the shape writer instead. What we can also see in this workflow is that we're writing out to a text file, so we're producing a report and some problems to Excel as well. So if we just run this process, reading in some data, and we'll read in the DWG and a tab file as before, and process that through. What I'll do is show you a little HTML page. This is a template that I've created that's a web page, and we can see that we've got a little problem report, and you can also see that there are some placeholders here for attributes that we're going to put the failure problem, the layer name, the total number of features. We're inserting those dynamically into a web page using this process. So very easily in this workflow, what you can see is I'm extracting information about the data. So I'm finding out the number of features by type that there are, sorting by the volume of problems, and I'm also getting a summary of the rows of data and inserting that, and I'm using a transformer called the XML templater, and this allows you to build up a little feature, and you can see here that I'm creating an HTML table into which I'm inserting a series of values. I use an XML template again to then insert those values as a dynamic list into essentially a web page header and a web page footer, and here is where I'm inserting the features. What we can then do when we run this is go to my output directory and open up the data report, and now you can see a dynamic set of values have been inserted into here. So you can have a hyperlink on an internal web page, and you could have this process run as a scheduled service overnight, and every morning this table would potentially be different. If I show you how that works, if I just prompt and run, and this time go and run this by just reading in some data from this Terrier data set as a shapefile, and run that on its own instead. What you'll see is that if we go to my output directory, where we're writing that out to, you'll see in a moment that we not only get a spreadsheet that contains the problems, and we'll see that we have a tab in there that shows us the types of problem, the number of features that were in the data, and the total failures. On a tab in the spreadsheet that tells us what the file name was. But we also have a data report which contains information about the problems that one table had in the same structure but a different format. And here you can see it's different to the previous one that we looked at. And all the individual problems are written out into a MIFMID, and we can overlay that data on our original data, or we can provide that to the person who created the data in the first place. I've just noticed we've had a question in that's asking, is there any way to search through data sets held within an Oracle database? Well, the answer to that is yes. In fact, one of the processes that I looked at originally for doing this was looking directly at an Oracle database. Your understanding or your requirements are that you need to have an understanding of the tables that you have in your database, and your Oracle Reader allows you to specify a dynamic table reading parameter. So at runtime, it will always update to check to see what tables exist in your database. So the same capabilities that I'm talking about here will work on a database with a few subtle changes to the way that you read that content. So hopefully that answers the question that's just come in. If you want any further follow-up, please just drop a further note into the chat window. So data quality in the cloud, moving away from the desktop briefly, is something that can also be done. If you don't have an immediate install of FME to get your hands on, you can get access to the very similar data quality rules and testing using OneSpatial's online validation service, which goes under the name of Socium. So if you go to the socium.co.uk website, there are a series of freemium rules, but also some premium rules that you can get access to. And everything I'm about to show you is freely accessible under the freemium capability. So you can see here that you can use a series of rules using a cloud-based validation service, and log into the page and essentially choose the rules you want to apply. So you can see that you can look for duplicate features, duplicate nodes, spikes, kickbacks, self-intersections, etc., etc. So a series of capabilities provided in this online service. All you need to do is log in, So you provide us with a bit of registration information on that website, and then you have the ability to upload a file. At the moment you can upload a tab file or a shape file to the service. You then upload the data, and it identifies the number of layers and features that are in the data set. You can see here we're identifying the layer names as well as the number of features in a planning data set. We're also have available a series of rules that we can drag and drop into the workflow, and once we've done that we can then validate our data, and you'll get back essentially a type of traffic light report that essentially tells you how conformant your data is to each of the rules that you've run on your individual data set. But the beauty of the system is also that you can download a validation report. So we can click on and download a zip file, and then open up that zip file that will contain a file in the same format as that you supplied originally. So you can see here that we have a series of points on the map that show us where we've got problems with our data. And if you take a look, you can see that there's an indication that there's a kickback at this location. So that attribute gives you an indication of what the issue is. So you can then go ahead and carry out some updates to that data, either by locally running that through FME to try and resolve some of the problems, or going through a manual process if the volume of data isn't too significant. So everything you've just seen there is free to use. You can access that service through socium.co.uk. Now, moving on to metadata, last couple of topics for this session. Metadata is a topic that is important to talk about under the banner of Inspire. Inspire, as I've already said, is a catalyst for data quality. At this point, having gone through a data audit and understanding where your data is and who owns it, and also having gone through a validation process, you are in a position to start the publication phase of your data processing. You'll see that over the last few years, a number of vendors have released Inspire applications, dedicated Inspire applications, and made those available to the market. The only challenge is that the Inspire mandate is and has been developing a lot over recent years. So it's been a little bit of a movable feast. And the other issue is that a lot of the solutions that have been produced sort of assume that you already have some metadata available. A number of the tools are essentially empty boxes that provide you with the Inspire schema that you then have to go ahead and populate. The handful of tools that are out there that will help you harvest information from your asset data only support a handful of formats, and inevitably don't support the main formats that you support your data in. So one thing that FME offers a great deal of capability is flexibility. The ability to adjust your workflows as you wish, and you have already heard me mention that FME 2012 supports over 275 different formats, which gives you a lot of capability both in the non-spatial and spatial arena, with 2D and 3D data, between raster and vector data, and also working with databases. The UK Gemini schema for metadata, UK Gemini 2.1, has 31 elements that have coded values that you can populate them with. And you can use FME to extract a significant number, almost half of the elements in the UK Gemini schema you can extract automatically via FME. And those that you can't get the values from automatically, you can use FME to join to a lookup table that you manage in a database or in a spreadsheet that helps you manage your asset. The other thing to be aware of is that you can react very quickly as an organisation with FME, because if anything changes, you can just adjust your workflow yourself without having to wait for a supplier to release a new build of software. So you'll see that if I go to the Association for Geographic Information, the AGI's website, earlier this year an amendment, or a potential amendment, was announced to UK Gemini 2.1, which is going to introduce a number of schema changes to the Gemini spec. The result of that is that in your FME workspace that carries out your metadata harvesting, you need make a few alterations only to then be compliant again with the metadata requirements. If I go and take a look at a harvesting process that I have in place, I'll just close down a few of my existing applications and take a look at what we have here. So I'm just going to go and get a harvesting process and drop that into the workflow. And you can see that again I'm employing the generic reader so that I don't need to specify the input format that I want to work with. And I'm also using a spreadsheet which contains a bit of information about the elements that I'm working with, and anything in black here is one of the elements that I can capture anything in red is something I can capture automatically using FME, and anything in black I look up from my spreadsheet. I've got a few coded domains listed here, so one of the domains that refers to the frequency of update is in here, as well as some of the topic categories in UK Gemini. And I'm also using a machine readable element in this spreadsheet, which is a tab called the Schema Mapper, and those of you familiar with the Schema Mapper in FME will know what I'm talking about when I highlight this. Essentially, the Schema Mapper allows me, as a transformer in FME, that allows me to join to this table and basically set certain values on my geometry based on the values that are stored in this spreadsheet. So, for example, the element title for a data set that has a file name of battlefield, the title will get set to be a battlefield. The beauty of this process is that you can give this spreadsheet to somebody who doesn't know how to use FME, give them the template and tell them to fill it in, or just update it. And an organisation I've worked with in the past built a little HTML form to join to a database table to allow the input of this information, and then you can just run your FME process on a schedule and produce new output each time. What we can see here, if I zoom in, is that some of these transformers are essentially populating the different elements in UK Gemini. So if I dive into here, we can see that this is populating the element called spatial reference system, and this is a transformer that's the coordinate system extractor. We can see that over here we're going to get the file path of the data set and get the file name and populate the alternative title. A counter gives us a number of features that are in the actual data set, which isn't an element that's in UK Gemini, but I haven't yet met an organisation working against UK Gemini who've decided that absolutely every element in UK Gemini is just perfect for them and what they need. Generally, organisations are interested in capturing other information as well as just the number of, as well as just the standard elements that are stored. Things like the bounding box or the bounds extractor allow me to extract the bounds of my data so I can populate the appropriate element. And I also need to be able to reproject my data to lat long 84 so that it's in the appropriate projection that is conformant for Inspire, and then I can extract out of that the bounding long and lat values. The Schema Mapper allows me to join to that spreadsheet that I talked about a moment ago and bring back any further information that can't be derived from the geometry, and then I can write the data out into a spreadsheet. So we can run this process on my source data and write out to a metadata spreadsheet, and when that's completed, what we'll be able to see, if I just go and close down the existing spreadsheet, is metadata harvested from my geometry, joined to the spreadsheet and produced in the appropriate format. And here is the result. So we can see that we've got title, alternative title, the dataset, language, an abstract for each dataset, as well as bounding box and the topic categories that have been derived from the coded domains. And as I say, 30 or so elements need to be populated to conform to UK Gemini. And you can write that output into a spreadsheet, or you could write it out into a database table to manage that information. So, just to complete this session, I want to talk about data sharing, because there are transformation challenges that you'll come up against in the future with Inspire. Ultimately, one of the requirements of Inspire, or a series of the requirements of Inspire, are about increasing the availability of data between organisations across Europe, making accessibility more easy, also looking at improving data quality and facilitating cross-border collaboration. But one of the main issues is looking at making sure that the compatibility of data is appropriate between not only organisations, not only countries, but also applications, making sure that interoperability is the watchword when it comes to your data. One of the processes that we've put together and presented at a number of the AGI events recently is looking at moving data from one repository through to Inspire conformant GML. And FME has a series of new capabilities in that area since FME 2012. Those of you who are familiar with the FME product will know that the XML capabilities of FME over recent years have grown and grown and grown to the point that now, for example, there is an Inspire reader in FME. So you can now open Inspire conformant GML and validate it directly within the Universal Viewer. What that starts to tell you is that you can start to build processes that produce your output that is mapping to the Inspire mandate. An example that we've put together that I'll show briefly is taking a Natural England series of data sets and processing those through to Inspire GML. Natural England have made some data available to us, and they do to everybody actually through the Magic website and their own website. So the sites of special scientific interest and Ramsar sites, which are international wetland areas, amongst other protected sites, are available to download. But Natural England themselves store the data in a database initially. So we have carried out the ETL process on a set of published files. Ordinarily, you would look at going straight to the source to produce the output. What we have carried out is a one-off analysis task, and that's something that you would do internally. Again, in a workshop idea, you would get together with your colleagues and take a look at your data and look at how your data's attributes map to the Inspire attributes. And you can build an FME workspace that basically manages that data mapping for you and ultimately writes the data out into the appropriate GML structure. The key thing really is that workshop. It will take you a little while to understand how your data maps to the Inspire target specification, but we have a number of experts who have spent time with organisations working on Inspire schema mapping, and what this can do is that you can prep your target to be able to accept the appropriate structure. This is again a bit of a spreadsheet exercise where you map your data to the Inspire classifications and make sure that all the elements are adopted. And what we ultimately do after we've gone through all of the different Inspire elements, so for example the legal foundation date, you can see that we have a series of descriptions here of what those elements should hold. we can then go and identify what attributes in your own data map to those. Building ultimately a machine readable spreadsheet, and the key to this process is indeed that transformer called the schema mapper. I would certainly encourage anybody listening today to go and take a look at FMEpedia.com and take a look at the schema mapper's capabilities. So with this example, we're able to basically work with any of the Inspire schemas. We've worked here with the protected sites theme and taken a look at the simple schema, but it could be extended to cover both the full and the Natura 2000 schemas that are available, and work on your own data. What we have done is build an FME workspace, and essentially that process reads the source data, reads the mappings from the machine readable spreadsheet, and embeds those into a series of XML templates. So you saw me using the XML template earlier on, writing out the data. The XML templates, there's just two of them. You can see here that this is the protected site simple schema. The key thing is that we've got some FME get attribute values here. So that using the XML templater, we can carry out essentially what is a mail merge. Those of you that have used Word in years gone by to carry out mail merges, to send letters out to lots and lots of different people, but insert different addresses and names into that template. That's the best analogy I can give you for how this XML templater works. You put a little character that basically allows you to get a certain value, a variable, and embed that into a template. And what we can do then is take that value, that list of features, and drop them into the GML header and footer, so that we build an Inspire conformant GML file. That's the location there. So the machine readable spreadsheet essentially tells us how attributes are renamed and how and when attributes are created and set to certain values. So for example, in the Sites of Special Scientific Interest dataset, there is an attribute that holds the name of the site, and in Inspire that maps to the site name element, which is a geographic name and contains the spelling of name and ultimately the text. When you have a feature that's from a SSSI site, you can also run a test to make sure that if it is, then we create this attribute, which is its type of designation, and set that attribute to contain the text protected landscape or seascape. So FME not only maps your existing attributes, but if your data does not contain an attribute that's appropriate to the schema, you can use FME to create that. So you can take your data and produce it and run it through your ETL process in a relatively quick time, depending on the volume of features you've got. And we're happy to assist with that kind of process if you want to take a look at approaches to producing conformant GML. If I just go and open up an example of the workflow, I'll just drag that across now. It looks like a large workspace, but you can see there's about 10 sub-steps in this workflow. Here we're reading data from MapInfo tab, but the data could be in any repository. And we're writing out to a text file, but essentially that is going to build our XML data. Essentially we go about making sure that the schemas are as similar to one another as possible. We make sure that we create an appropriate URL that can go into the web resource element that's required, and we can build that up from citation information that's available on the web for that data. Create any attributes that need to be created. Designation date is one, for example, that needs to be created in our data, and get any layer names that can help us understand where our data comes from. And then the key process is to use the schema mapper to dive into a spreadsheet in this case, but it could be also connecting to a database to map any attributes where the attribute in your data needs to be mapped across to join to an attribute that's in that lookup table. We need to reproject our data to reproject it into ETRF89 so that it's Inspire conformant. I'm extracting the geometry from the process to make sure it's as efficient as possible and generating a unique ID, because some of my data doesn't have a unique ID. And then I'm inserting the content into those templates. So here's my GML schema, and I'm inserting into here the geometry between the required geometry tags, and ultimately writing it out. So if I just process this through, I'm just going to send a sample of my data to my output, and you can see that as that runs, we're building a GML file here. And if I go and open up the Universal Viewer, a couple of things we can do is we can open up a data set, and you can see that we now have the ability to open Inspire GML. And if I go and just grab that file, it's going to let me do that, grab that file and drop it here, and just dive in, we can see that we can flatten any nested attributes that are available in this data set if we wanted to. Read in that Inspire GML. We also have a parameter on read that allows us to basically check that against the XML schema to make sure that it validates correctly. And here we can see if we click on one of these features, we've got the data and all of the appropriate elements in Inspire written out into the data. And it's also, as you can see, reprojected it to EPSG 4258, which is that ETRS89 projection system, which is appropriate for Inspire. So, a rather technical webinar today, looking at some of the capabilities of FME around Inspire. Some simple capabilities, some more complex. The main message to take away from today is that Inspire should be treated as an opportunity to not only understand where your data is, but also what quality that data is, and also be aware that FME has a lot more capabilities than those headlines you might have read on the SAFE website or at the last webinar that you sat in on. FME has a lot of capability to translate and transform data and restructure it so that it can be fit for use. The other thing to be aware of is that you may have bought FME in the past for a particular task. You can look to repurpose it for a number of different tasks because of its level of flexibility. Inspire gives us the ability to improve our data. FME 2012 certainly supports working with Annex I, II and III themes, and you can see that we've got the ability to read Inspire data, and there is an XML validator transformer in FME as well that allows you to make sure that any schema definition files you have that you've downloaded from the Inspire website, you can just run against your data with that XSD to make sure that it's conformant. We've run this session for about an hour now. We've come to a close. I hope you found this session useful. If anybody's got any further questions, please feel free to drop them into the chat window and we'll deal with those in a moment or two. But for now, I'd like to let you have a few post-training resources to take a look at. If you want to download FME Desktop or Server, you can go to our website. It's onespatial.com/FME. If you email us at fme@onespatial.com, you can get access to an evaluation license for those products. You can also comment on this training. You can sign up for the next webinar, which looks at data.gov.uk in about a month's time. And you can also download or find out more about the UK postcode validator, which is a custom transformer that we released into the FME store, which is brand new to FME 2012, and we've put that up and have made it available on our website, and it's also available in the FME store. You'll also see the URL there for SAFE's website, certainly the place I would recommend you going to, where there's over 1,000 articles, is fmepedia.safe.com. You'll have access to the FME Talk chat room, Google chat room, to work with other FME users. Do take a look at the Evangelist blog, and also search for FME channel on YouTube, where you'll find details of capabilities with FME, and be able to take a look at different abilities and different techniques that you can use with both FME Desktop and Server. You can also see that we have our own YouTube channel where our webinars are being posted. So this session will be recorded and put up onto YouTube, as well as our own website. So if you want to go to youtube.com/OneSpatialGroup, you'll find the other webinars in the series, as well as this one soon. For now, though, I'd like to thank you all for spending the last hour with me. My name's David Eagle, Principal Consultant at OneSpatial.